In this video, we will cover different parts of the atom. So with the atom, it is the smallest particle of matter. It is mostly empty space with a tiny nucleus. So the atom is made up of smaller parts that are called subatomic particles. The smaller parts that come together to make up an atom, we call these subatomic particles. The three main subatomic particles are protons, neutrons, and electrons. Most of the mass and weight of the atom is found in the central part of the atom, called the nucleus. So the protons and neutrons we find in the nucleus, and then the electrons, they orbit the nucleus at great speeds in rings called orbits, or energy levels. So as was stated at the top of the slide here, an atom is mostly empty space with a tiny nucleus. So you find the nucleus here with the protons and neutrons, and then in different orbits or energy levels, you find those electrons. And electrons are very tiny, and they're spread out very far apart. So there is a lot of distance between electrons in the nucleus and even electrons themselves. Now we'll look at some characteristics of the different parts of the atom. So we have protons, which we can represent as a lowercase p with a subscript positive sign. So we can shorthand protons with this symbol here. Protons are found in the nucleus. The relative mass of a proton, we'll say, is 1. Protons are so small that to compare or to write down their actual mass, you're dealing with a very tiny number. And this is the relative mass compared to other subatomic particles, so protons, neutrons, and electrons. The charge, the electric charge on a proton, has a charge of +1. So protons have a positive charge, hence the plus sign. Neutrons, we can abbreviate as lowercase n with a superscript 0. Neutrons, we also find in the nucleus. They have a relative mass of 1 as well, which means protons and neutrons have about the same mass, or we say the mass of a proton is equal to the mass of a neutron. The electric charge on a neutron is 0. It does not have a charge. It is neutral, hence the word neutron. And then the last parts are electrons, which are abbreviated with E and superscript negative sign. They are found in orbits around the nucleus. The relative mass of an electron is 1/2000. So it would take 2,000 electrons to equal the mass of 1 proton or 1 neutron. So electrons are very, 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 very small compared to protons and neutrons. They are just tiny. And then the charge, it has an equivalent charge, and this is just how things work at the subatomic level. Electrons have a charge of -1. So they are negatively charged. Elements are arranged in what's called the periodic table in order of their atomic numbers, and we'll go through what those all mean. So, but first, here is the periodic table, which contains all the known elements, natural and synthetic. And organizes them in a particular way, and then each element is represented by a particular symbol as well, which we'll get into later on. So once you start learning about the periodic table, it's very good for being able to make some jokes here. You have various elements on here, like hydrogen, lithium, beryllium, boron, oxygen, argon, neon, helium. And if you're, creative enough, you can start to use some jokes with these. So, I'd like to tell you a chemistry joke, but all the good ones are gone. Argon is an element on the periodic table. Want to hear a chemistry joke? C. Want to hear a Spanish chemistry joke? C. Si is a silicone on the periodic table. And if you're thinking, wow, this is really not that good, we can take all these chemistry jokes and barium. Barium is an element on the periodic table. So as you can see, a lot of good uses of the periodic table exist. So using information from the periodic table, we could come up with what's called atomic notation. So atomic notation gives us information about an atom's subatomic particles and can be represented using standard atomic notation. This this form here is standard atomic notation, and this gives us information about the subatomic particles in an element or in an atom. So with that standard atomic notation, you have the symbol for the atom, symbol for the element, and then written on the left-hand side, superscript is the mass number, and we'll go through what is the mass number. And then on the left-hand side as well, subscript is written is where you would write the atomic number. So this form here is standard atomic notation. So when representing the elements, chemical symbols are assigned to elements as an international way to represent the element regardless of language. So the chemical symbols are basically a short form used to represent the names of the elements. So what those chemical symbols are one or two letters. The first letter is always capitalized, while the second letter is always lowercase. So how you write those chemical symbols conveys important information. So for example, calcium has a chemical symbol of Ca. The first letter is uppercase, always uppercase, capitalized, and then the second letter here is lowercase. So we have C, A, lowercase. Silicon, for example, is Si. That second letter is lowercase in this case. If the symbol is just one letter, that letter is capitalized. So iodine is just represented by a capital I. Some of the elements were discovered in ancient times and have Latin names. As a result, some elements have chemical symbols that are based on their Latin names. For example, the symbol for gold is Au, which is from the word aurum, which is Latin for gold. Now, on the periodic table, how information is presented gives you can give you an indication of the subatomic particles contained within an element. So on the periodic table, generally speaking, you'll have the element symbol here. This is the atomic symbol telling you what element is being discussed or represented here. So in this case, He is going to be helium. And then you have the atomic number, which is placed above the symbol, and the atomic mass placed below the symbol. So in the atomic number, which goes above the symbol here, the atomic number tells us how many protons are in the nucleus of one atom. So this atomic number here for helium tells us that helium has 2 protons. And keep in mind that the atomic number identifies an atom as a particular element. Each element will have a unique atomic number. If you change the atomic number, you change the number of protons in the nucleus. And when you change the protons in the nucleus, you change the identity of that element. So every element in the universe that has two protons in the nucleus will be helium. Every element in the universe that has one proton in its nucleus will be hydrogen, and so forth and so forth. So the number of protons is how we identify that particular element. So the element with an atomic number of 6 is carbon. Carbon has 6 protons. Every carbon atom in the universe has 6 protons. If a proton is added or removed, the atom is no longer carbon. It is now a different element. In any neutral atom, and this is an atom that does not have a charge associated with it, the positive charges and negative charges must equal each other. Therefore, 3 pieces of information are the same for a neutral atom. So the number of protons will also tell you the number of electrons. Remember, electrons are negatively charged, protons are positively charged. If we are dealing with a neutral atom that has no charge, no overall charge, the positive charges must equal the negative charges. So the number of protons must equal the number of electrons. So the atomic number of an element will tell us the number of protons in the nucleus and will tell us the number of electrons in a neutral atom. So you can use your periodic table to check the following for lithium. So identify its atomic number, number of protons, and number of electrons. We can take this information up during class. The last thing that we'll talk about here, or one of the last things that we'll talk about, is atomic mass. Atomic mass is the sum of protons and neutrons in the atom. It is also referred to as the atomic weight of the atom. So the atomic mass is that last little bit of information that we'd find in a periodic table and in standard atomic notation. Remember that the mass of the electrons relative to the mass of the protons and neutrons is insignificant. Remember, it takes 2,000 electrons to equal the mass of one proton. No element has 2,000 electrons in it, at least that we know of. So the majority, the vast majority, if not all of the mass of an atom is going to come from the number of protons and neutrons. So the atomic mass of that element tells us the sum of protons and neutrons in the atom, in the nucleus. So if you know the atomic number and you know the atomic mass, you can calculate the number of neutrons. So if you take the atomic number, which remember is number of protons, this will help you to determine the number of neutrons. So the atomic mass, or that atomic mass number, is equal to the number of protons plus number of neutrons. So if you know the atomic mass, you know the number of protons, you can take the atomic mass, subtract the number of protons, and you will get the number of neutrons. So the atomic weight for each element is also found on the periodic table. So generally speaking, the way to kind of figure out which one is atomic weight and atomic number, between the two numbers, the smaller number is going to be the atomic number. This is just number of protons, which is equal to number of electrons. Remember, atomic weight or atomic mass is protons plus neutrons. So this number is going to be bigger. So if you take this number and then subtract this number, you get the number of neutrons. And if you're looking at this example here of krypton, and you're thinking, well, I'm going to get a decimal when I calculate the number of neutrons, that is correct. We can talk about why that is in class. But the way to deal with that is just round up. So I would round this number up to 84. And then subtract 36 from it to get the number of neutrons for krypton. So I'll let you work through this example here for krypton, determining its atomic number, atomic mass, number of protons, number of electrons, and number of neutrons, and we can take that up in class as well. So just to review here, three key bits of information that you need here is when looking at the periodic table is you need to know the atomic symbol, so you need to know what symbol is being or what symbol refers to what element, the atomic number, and the atomic mass. This portion here just summarizes the calculations that we talked about. So that is the end of this video for parts of atom. Given all that information now, you can feel like super powered and supercharged, and you can become a radioactive person.